Okay, as a continuation of this problem of solving a non-homogeneous linear differential equation, second order, by undetermined coefficients, I'll take the same thing, exact same problem, solve it by variation of parameters. Why might we do that? Well, if we solve by undetermined coefficients, we have to have this non-homogeneous element that take a certain form. It would be linear, quadratic, exponential, sine, or cosine. If it's not, then it's hard to solve by undetermined coefficients. Variation of parameters, it doesn't really matter what that thing is right there. Okay, so here's the general method. Okay, so that kind of problem has this solution. There's the general. You know what y sub c is. That's the solution to the complementary homogeneous equation. And yp is any particular solution to this the way it's given. Okay, we can find that, like I said, by undetermined coefficients, which we have already done in another video. But variation of parameters would give it to us this way. And you'll have to just take that formula face value. I'm not going to explain where that comes from in this video, but that's what it is, okay? And notice the elements of this. I got y sub 1 of t and y sub 2. Those are any two linearly independent solutions to the complementary homogeneous equation. Okay, that's what they are, and we should be able to find that. And about v1 and v2, well, that's what we don't know. That's what the method allows us to find. You find v1 and v2 out of this system, where that's a 0, and this is whatever that function is. Okay, so that's what you do. Now, let's start by finding y1 and y2. So, first part of this, for me to find this set of two linearly independent solutions to the homogeneous equation, well, that would be like solving this, giving us that characteristic equation and these roots, and there are the two linearly independent solutions expressed as that linear combination with unknown constants. So let's do this. Let's say that's just going to be, by our work elsewhere, whoops, let's do like this. E to the t power is going to be that, and e to the minus t is going to be this. So that's y1 and that's y2. Okay. All right. Now, from here, it's like, I don't know what v1 prime is and v2 prime. I mean, I definitely don't know what v1 and v2 is, but, since I have these, I guess the objective is to find v1 and v2. And you find them out of that, like this system right here. So what we ought to do is just write that down, okay? So here goes. Second step, the system that you see right here is going to look this way. We'll say v1 prime, and I'll drop the of t part, it's a function of t, times y1. That's going to be times e to the t power. And then v2 prime, I'm just going to write like so, times e to the minus t. And that is supposedly equal to 0. And we're going to accept that, not question it. That's what it says, so that's what we'll do. And then the next equation in the system, v1 prime times y1 prime. So that's going to be like this. What's the derivative of that? If that's y1, it's still e to the t. And then plus v2 prime times y2 prime. Well, if y2 is this, its derivative is negative e to the negative t. So let's do like this. All right, v2 prime and a negative 1 e to the minus t. Okay, this should be whatever that non-homogeneous element of our original problem is. And in this case, it's e to the t. All right, now I've got to solve this. Now, this would not be so different than solving a 2x2 linear system in basic algebra. Okay? And I've made another video elsewhere about Cramer's rule for solving such a system, and that's what I'm going to do here, is just use Cramer's rule. Okay, so Cramer's rule it is, and here's what we'll do. We'll solve for v1 prime first, okay? And here's how I set up the determinants to do that. What are the coefficients of the left-hand side of this system? The coefficients being, I'm trying to solve for v1 and v2, so they're multipliers. It's going to look like this. I get e to the t, and then also in that column e to the t. Here I get e to the minus t, and here I get negative e to the minus t. So I would have to find the determinant of that to do this. Above it, okay, here's what we do. If we want to solve for our first unknown, and this first column happens to be v1, I replace the first column here with 0 and e to the t, which are these, okay? And then I replace only that column. Otherwise, this other column should be e to the minus t minus e to the minus t. Okay. So apparently that's v1 prime. That's what Cramer's rule leads us to do. That is going to be this. We calculate such a determinant by multiplying diagonally this way. And I'll get a negative e to the, what if I add those together, 0. So negative e to the 0. And then I subtract and I multiply diagonally this way. I'll get another e to the 0. Looks like that. On top, I multiply diagonally in the same fashion as I did down there, so that's 0. And minus, what's that? That's going to be e to the 0. So I get nothing but a negative 1 over negative 2, so we'll just say half. Now, if that's v1 prime, then I can tell you what v1 is. It's 1/2 t. All right, we would just integrate that. So let's say that we could do that. That's not hard. We'll do that in another step. Let's go ahead and find this other unknown, v2 prime. So here goes, v2 prime. So if I'm going to solve for the variable in this system in that column, this part's not going to change. It's just I would replace that second column with 0 and e to the t, which is what's over here. Okay, so I'm going to say negative 2 because that's what we're going to get if we redo it. And on top, I'll leave this column the way it is. And it's that's the one now I'm going to replace with 0 and e to the t. Okay. So I do the math from here, but that's going to give me v2 prime. As far as what that is, so multiply diagonally like so, that's going to be e to the 2t. Okay. And then minus whatever this times 0 is, which is just 0 anyway. And then over negative 2. So let's call it negative and put a 2 like so. All right, now these are v1 prime, v2 prime. You want, if we look back here, I know you could forget what we're doing, but I want v1 and v2. There's this y sub p, which is part of the general solution to that. Okay, so I need to integrate both of these to find v1 and v2. So let's do this. Let's say, look, we get v1 of t is just t over 2. And then from this one, if we integrate the same way, we'll get v2 to be negative e to the 2t over 4. If we do the integration, that's what we're going to get. Okay, now I have everything I need to find this. Okay, I have y1 and y2. We talked about what they were, and we found them. And now I have v1 and v2. So here's what I get. Say I want now that thing. So ypt. What's v1 times y1? Well, let's see. There's v1 and there's y1. That's going to be 1/2 t e to the t. Okay. All right. And then what? Plus v2 times y2. So v2 is this, and y2 is that. So say you multiply those together, it's going to be negative 1/4, and then you add the power, so e to the t. Negative 1/4 e to the t. Okay, so there's that. Now, I found this, and then I know that one already, and the general is made by adding them together. So here's yp right there, and we know what that is. So here's the general solution. That original problem is going to be like this. Y is equal to, what would this be? The solution to the complementary homogeneous? Well, those are the elements of it right there. So we'll get c1 e to the t plus c2 e to the minus t. Okay, and then plus this thing, 1/2 t e to the t minus 1/4 e to the t. So that should be our general solution right there. That should be our general solution to this. Now, at this point, I'll have you recall we solved this same problem in another video by undetermined coefficients. And I got that. And, you know, we're not quite there yet. You know, this obviously does not look the same as this other answer. And there should only be one answer to that. So I would notice about this that I can do some more work to it and reconcile what I have here with what I already found the solution to be in another method. Okay, so what I notice is that those are basically like terms, and I could say there is a coefficient of that on e to the t. You know, take this and this, and that's different. So I'll say plus c2 e to the minus t, and then I get this, which I can't combine with anything, plus 1/2 t e to the t. Now, all right, that's more like it. You see, these are essentially the same. That's a constant times e to the t, some other constant times e to the minus t, and then plus this, 1/2 t times e to the t. So they're the same. That's a constant just like this is, so it doesn't really matter that it looks a little bit different. So we could just call that C1 if we wanted to, and we get essentially the same answer as we got when we solved it by undetermined coefficients. Okay, so formally I'll go ahead and write it like this. All that would reduce to, all it would be seen as, for the sake of solving a differential equation, is this, and that's what will give us our final answer for the general solution.